I've never used a microphone before.
You're good.
All right. Okay, so show of hands, who's heard of Kotlin? Sweet. That's actually more than I expected. It's kind of an esoteric language, and I'm kind of an esoteric person, so it works for me. My name is Nick Billick, and I'm actually from the Flash community, which everyone knows is now long and gone. My history is I was in the Flash community for most of my career. Flash, Java, a little bit of C#, a little bit of server-side languages, a little bit of everything, but primarily Flash. And I worked at Riot Games in front-end game development. So it was a lot of very heavily designed work. It was very, it had to be pretty, it had to be animated, it had to be scalable. We were working with lots and lots of code that needed to stay stable, it needed to scale, it needed to be fast in iteration time, all those good things. After Riot, I started doing independent game development, and I like the browser. A lot of games, they're done in C++. That's what we did at Riot, and I wanted to stay in the browser. And with the death of Flash, I tried a lot of different things. I tried Dart, I tried TypeScript, I tried JavaScript, and the common theme of what I was searching for, the common theme of what I was searching for was something that was statically typed, had really good tooling, and could scale immensely. Something I could write 150,000 lines of code in a project, and it still stays up. I can refactor. I can use all the things that I was used to being able to do with ActionScript and with Java. What I ended up starting on was a game framework called Libgdx. So Libgdx, what that was is a Java framework for games that was an abstraction to OpenGL and WebGL. So you could do OpenGL on the desktop, WebGL on a browser, or on mobile it was OpenGL ES. So it was an abstraction layer to OpenGL that you could write once and run it everywhere. And I really liked that, but the workflow to the browser I felt was really crappy. It was using GWT. I don't know if anyone's used GWT here. It's a good idea. The things I find lacking with it is it's really hard to debug. The workflow is very slow and cumbersome. You have the nice tooling, you have the nice language. It has the scalability that I'm talking about, but GWT, the workflow and testing it was. It wasn't JavaScript. Like at that point, I almost would have rather used JavaScript. So what Kotlin is, and Kotlin's a very new language. It's been around for about 5 years, but they didn't get into they didn't release until just recently. So they hit 1.0 for the JVM version. They're still in beta for the JavaScript one. Oh, I don't know if I mentioned. Kotlin is a language that goes both to JVM bytecode or to JavaScript. Someone asked on the meetup group, well, how does it differ from LLVM transpilers? The way that it works is it's more similar to TypeScript for the JavaScript side. So it actually takes the language itself and writes out plain JavaScript. It doesn't convert LLVM bytecode. It doesn't take Java code and turn it into JavaScript. It takes your Kotlin code and turn that into JavaScript. So I went to Kotlin Lang. Let me go back 1 second. I think it was kotlinlang.org. Yeah. So kotlinlang.org, this is where you can get started. And they have plenty of getting started examples. and I'll start with something very simple, and then I'll show you something to sort of whet your appetites of like what you can actually do with Kotlin, like what makes it cool. Okay, so they've got a try Kotlin in the browser, so we can start messing around here, and I think I would sooner start with like the tutorials. I'm just going to show you how their online in a browser works. So the language here, let's see. So we can actually run it as JavaScript. So we're seeing the console right now, and we can also run it in JVM. So this is the same code running in either JVM or JavaScript. So the generated code, this is the generated JavaScript code. It's not something you typically use directly. You get a lot of mangled names, things that are supposed to be private. Obviously, JavaScript doesn't have such a thing as private or protected or namespaces or anything like that. So, so the code that it generates, you're going to have like, pretty much generated code that you're not going to be able to use it very well with plain JavaScript. So you can kind of go the other way around. You can write Kotlin code that makes use of other JavaScript things, but the other way around is a little difficult right now. And as I said, that the JavaScript version is still in beta. It's not it's still got some ways to go in terms of like the JavaScript version doesn't use modules yet. If you want to write APIs in Kotlin that are used by other JavaScript things, by other plain JavaScript things, that workflow's not so great. But from Kotlin code, you can access JavaScript. We can access. Well, here, let me use the IDE so that I actually have something to do. Okay, so what I'm doing is I'm creating a main function that's the entry point into your application. Kotlin is a object-oriented language. It's the architecture is very similar to Java. If you are a Java developer, you'll find Kotlin to be very quick to pick up. There's several differences. Kotlin is more terse, it's more concise, it's more safe. So Kotlin has things like it has null safety, so you don't hit the same sort of runtime exceptions that you do in Java. A lot of times in Java, like, it is statically typed, but because there's no null safety, it's like every single thing that you're doing, well, it's two types. It's whatever you declared it as or null. So the static typing in Java, just from null safety alone, makes Java really hard to use, in my opinion. So what Kotlin does is, you see this in Apple's Swift as well. It's got null safety, and so if we have a type that can be nullable, like for example document.body, we have to assert that it's not null if we want to use it. So so this what that means is, like, I'm saying document.body, and in this specific case I know that I've got one because I'm waiting for the window to load, and because the HTML page, I created a body, so I know it has one. So in that case, it's asserting that that's not null. And where it becomes more useful is if you've got a function, things like that take non-null types, and when you call that function, you're guaranteed to have to pass something. Okay, so here I'll just run this example. So what this did was it ran in the browser, it created this JavaScript file, and once the window loaded, I created a div and then set the text content on it and added it. Now I know that this is kind of a silly example. That's not really how you develop something, but the idea is that that the workflow is I can write my object-oriented programming in Kotlin, and then it's a pretty quick iteration for getting this into JavaScript and getting this into a browser. Okay, so if any of you are familiar with IntelliJ, what I'm kind of trying to show is that in IntelliJ, you get live highlighting. So you're kind of sacrificing a little bit of iteration speed. Like JavaScript's incredibly fast to iterate, like what we just saw with hyperdev. I mean, that was really awesome when you're talking about things like designing something, making something look pretty, getting the user interface to feel just right. That iteration speed is key. So there's sort of two things that you're really trying to juggle when you're making a really large application. One is to make sure that it can scale, that we can easily refactor it, that we know when we've done something wrong before runtime. So we want to catch problems as soon as we possibly can. And then you want to be able to refresh and see your changes as fast as possible so that you can iterate on it and make it feel good. And I feel like Kotlin has a nice balance of that. So right now I'm creating a class, and I can put this in a new file. I'm just doing this for demonstration purposes. But I create a class. I'm implementing the callable interface, and now I can actually just autocomplete these methods. There's a lot of like autocomplete and intentions and things like that with Kotlin that just makes it really it feels nice to use. There's a lot of shortcuts that IntelliJ gives you. There's a lot of assertions and checks in place that makes it so that I can do this. So again, like I'm running this and I know that I've got the code correct because the IDE is telling me right away. Okay. My computer is really slow on battery power. Okay, so here's an example of that. I'm gonna jump over to something that I've been working on that I write the same code in Kotlin, and I use it both on the JVM and JavaScript. And out in production, the people that I know that use Kotlin, the vast majority of them are using it for things like Android. And that's because Android runs Java 6, and so they don't have the newer Java 8 features, and so they use Kotlin to get those features when they otherwise wouldn't have them. So right now, like one of the biggest areas of use for Kotlin is Android, and also it's making a stand in the server side programming because it is more safe. It's Java, in my opinion. It's like hearing yourself talk. I would have had to say, this div is an HTML element. Java, or sorry, what does that create? An element? node. Yeah, okay, element. So like in Kotlin, it's statically typed, but there's a lot of inference. So I didn't need to say that this is an element, because of course it's an element. Create element gives you an element. If I wanted to say that this was, I could cast it as a div element, and now this div is type HTML div element. Okay, let's get to the other example that's a lot cooler. Okay. So what I've got here is it's a little example of using the Spine runtime. So Spine is a skeleton animation framework, and what I've got is I've got a Kotlin library that I wrote that takes the Spine skeleton, uploads the vertices to the GPU, and then is able to render them either in WebGL or in OpenGL on the desktop. Okay, so this is using the tool Spine to create this animation. So we've got a skeletal structure here of bones, and we've got a mesh around each bone. So we've got we've got a sprite sheet that that has all of the textures in this, and then in the tool, I can show you the tool a little later if you guys are interested, but what the tool does is it lets me set points all around the tail, all around the dude, and I can actually do freeform deformation, I can do inverse kinematics, I can make this animate not using a sprite sheet. So like if we had this be like a typical sprite sheet animation where we've got each individual frame like a flip book, this would be very large. It wouldn't be as smooth, because here I can run at 60 frames a second, and when I jump, you notice that he's actually like moving down into the jump. It's a nice transition between the walk and the jump, and I can animate things independently. So I can have him draw his gun and not interrupt the walk animation. I can have things work independently of each other. So I'm showing you this in a browser on WebGL, and just to prove that I'm not making stuff up, let's do it in. Sorry, I have to exit presentation mode for just a second because I need to switch my run target. So now I am running that same example in the JVM. So the way that this works is I've got a build set up so that it takes the Kotlin code, runs it in JavaScript, and creates JVM bytecode from it. And then I've got two backends. I've got a JavaScript backend and a JVM backend. So here's the same thing on the desktop, and I could do the same thing with Android. I can do the same thing with iOS using RoboVM. RoboVM would let me convert that would let me convert the Java bytecode to iOS bytecode. So now one thing that I really like is I like the workflow where I can debug this in both the JavaScript and JVM version. I really should have plugged in. My computer's like 3 times faster when it's on actual power. All right. so here we hit a breakpoint, and again I could have done this in JavaScript as well, and I can see everything in here. I can see my data. I can see exactly what's happening, and I could even I don't know if this works with Kotlin yet, but IntelliJ has something called Chronon, where I can actually record stack frames, and so every step of the way I could actually go backwards in time. So like if I hit a bug in a game, I can actually go backwards in time to see how that happened and stuff like that. So so the tooling around this just makes it so that I can debug very, very complicated bugs easily. Okay, anybody have any questions? Yeah.
Yeah. So I noticed when you showed us the demo in the web browser that it loaded a file called Kotlin.js from the lib directory.
Mm-hmm.
So does that indicate that does the compilation to JavaScript happen like offline with like a pre-compilation step, or does it happen like in page and you just have your Kotlin script?
Oh, it is offline. Yeah, the Kotlin.js, that's a runtime that it needs.
Oh, okay, gotcha.
Yeah. And there's a small Java runtime as well.
Understood.
Yep.
Right on.
Yep.
How does this compare to other languages that are JVM and JavaScript compilers? So the only other one that I know of is what, Solana?
Is what?
Solana,
I'm not familiar with that one.
Oh.
The only other one that I've used that is both JavaScript and Java is GWT, and the thing that I prefer about this is that it's a lot easier to debug. I can actually set breakpoints in my IDE with GWT. You have to like run in like some debug server, and you can get a stack trace, but you can't actually debug live variable data and stuff like that. Okay.